This is an attempt to concretize the nth term procedure that we normally do. The idea is that students will build their own version of the shape and thus reveal the structure, and the aim is at the end that they will of course move on to do what they normally do in the just totally abstract. A couple of conventions. The app that I want to doesn't actually exist yet, though I'm hoping that Jonathan Hall from Mathspot may yet do this. What I'm using here I'm calling number rods, because Cuisenaire rods don't generally have numbers on them, because any rod can be any number. So we'll call them number rods, and the convention I've done is the line here in axis is that if they're above that they represent positive, and if they're down below here they're negatives. There are no negative number rods around at the moment I'm aware of, so that's what I'll be doing. I will, even when we hopefully get some negative number rods, I will still follow the convention of putting them below, because that worked out the best for me. The other difference is that 3n, when you're building, say, algebra tiles, normally means 3 lots of x tiles. But in this context here, as I've done in the past with Diophantine equations and counters, 3n means a rod of 3 times 1, or a rod of 3 times 2, or a rod of 3 3 times, or a rod of 3 4 times 4. So the 3 is the value of the rod, and the n is the number of them that you have. Lots of aims. Reveal the structure of the linear series. Bring some meaning, something tangible, something inactive, something that you can move and build, what the comma difference means, rather than just numbers, and understand what the term 0 means, bringing some concrete meaning to that, and therefore get to how to derive the nth term by looking at the difference in term 0. I'm going to start with a very simple series, but sort of establish a routine that we're going to do. Now you'll notice that these towers, if you want to call them that, columns are getting taller. And what we want to do is to look at the difference first of all. You see this one's gone up by 1 from the previous one, and this one here is gone up by 1 there, and this one's also 1 more than the one before it. So that tells us that the basic building blocks here are 1s. And if we fill in the rest of these, we'll see that the first one is made up of a 1 rod times 1, the second one is made up of a 1 rod times 2, the third one is made up of a 1 rod times 3, etc. So for example, the 10th one would be a 1 rod times 10. So we could say that the 10th one would be a 1 rod times 10. So it would be 10 tall. And if you want to talk about any number I want to say, it'll be 1 rod times whatever number column I want to go to, whatever term in the series. Now here's another one, and in order to break down the structure of this to reveal it, we first of all need to look at the difference, where we can see that this one here, for example, is 2 more than the preceding one. So that means we are dealing with building blocks of 2. So the first one in the series is made up of a 2. The next one is made up of a rod of 2 times 2. The next one is made up of a rod of 2 times 3, etc, etc, etc. So we can see we've made a copy over that, but this time we're revealing the structure, what's going underneath the bonnet. So the fourth one in this one would be a number rod of 2 times 4, or the 2 rod 4 times, and that would be 8. So whatever number column or term in the series I wanted to make, it would be the 2 rod times n. Again, to reveal the structure, what's going underneath the bonnet, we need to look at the differences. We can see that this one here is 3 taller than that one, and that's 3 taller than that one. We can see that that one's 3 taller than that one, 3 taller than that one. So the basic building block of this one is 3s. So the first one is a rod of 3 times 1. The second one is a rod of 3 times 2. The third one is a rod of 3 times 3, etc., etc. So if we wanted to work out the fourth one, which you can see in front of us here, so we can check, the fourth one should be a rod of 3 4 times 4, which is 12. So whatever number we wanted in the diagram or in the series 3, 6, 9, 12, it would be a rod of 3 n times. So here we see a perfect copy of that, but here we've revealed the structure, how it's being built up, what's going on underneath the bonnet.